Today we're going to look at some advanced systems of equations and how we can solve them using substitution. So we're going to use the same concepts that we learned in section 7.2 about solving simple systems. It's just that we have to think a little bit more critically about the systems in questions because they're going to be a little bit more complex. Now the substitution method is sometimes can be used whenever you find a common factor. And then things still are pretty simple. So for example, 1, we have 3x plus 7y equals 34, and 2x plus 4y equals 20. So for this one, we can solve for x in the second equation, and the reason that we are going to want to solve for x in the second equation is because 2 and 4 share a common factor versus 3 and 7 don't. So now when we try to solve for x here, we'll start with subtracting for y, but when we divide by 2, we're able to divide everything by 2, and 2 goes into everything evenly. Versus if we were to try to divide everything by 3 over here, we would get fractions. We don't really care for fractions. So the reason that we chose this equation was because 2, 4, and 20 had a common factor of 2, which is what we would have to divide by to solve for x. So first step, subtract 4y from both sides, then divide every term by 2, and we end up with x equals negative 2y plus 10. Now we can use that expression and substitute it for x into the other equation. So instead of writing 3 times x, we have 3 times negative 2y plus 10. And then we'll bring down the rest of the information, plus 7y equals 34. Now we have an equation with just one variable, which means we can solve for that variable. We'll start with distributing that 3, and then we get negative 6y plus 30 plus 7y, and negative 6y plus 7y will give us just y, or 1y, plus 30 equals 34, which means y is equal to 4. Now that we know what y is equal to, we can go back and solve for x. We'll substitute the 4 for y in the expression equation x equals negative 2y plus 10, which means that x is equal to negative 2 times 4 plus 10. So see how we just replaced y with 4 since we knew that y was equal to 4. So negative 2 times 4 is negative 8, and then negative 8 plus 10 is 2. So now that we know that x is equal to 2. So our solution written as an ordered pair is 2, 4. Alright, so sometimes, unfortunately, we can't avoid fractions when solving by substitution. So since we can't always avoid fractions, we have to remember how to eliminate the denominator and look for common factors so that way we are substituting the right variables to make it as easy as possible. If the coefficient, which is the number that comes right before the variable, of a term is a factor of the like term in the other equation, you want to solve for that variable. So let's look at an example. We have 2x plus 3y equals 16, and we have 4x plus 5y equals 28. So notice that 2 is a factor of 4. So what we're going to do is we're going to solve for x over here. So we'll subtract 3y from both sides. And then that means x is equal to negative 3y plus 16 over 2. So instead of dividing every term by 2, what I'm going to do is I'm going to leave it as one big fraction for now. And the reason that I'm going to do that is because remember we said that 2 was a factor of 4. So when I substitute this big O expression for x into my other equation, I'll have 4 times that whole big equation plus 5y equals 28. But notice how the 2 and the 4 are going to reduce. That was the whole point of solving for x here, since 2 was a factor of 4. So now 2 goes into 4 twice. So now we have 2, parentheses, negative 3y plus 16. So this 2 went away because it went into this 4 twice. So that's what happened to this 2. It didn't just magically disappear. We did 4 divided by 2 and got 2. So now we have an equation with just one variable, which means we can solve for that variable. We'll start with distributing the 2. So we have negative 6y plus 32 plus 5y equals 28. Combine like terms. Negative 6y plus 5y is negative y. Subtract 32 from both sides. 28 minus 32 is negative 4. We will multiply both sides by negative 1. So we'll get our positive y here. Y equals positive 4. Now that we know what y is, we can substitute it back into the equation for x and solve for x. So negative 3 times 4, since we know that y is equal to 4, plus 16 divided by 2. So we have negative 12 plus 16 divided by 2, and that gives us x equals 2. So our solution as an ordered pair is 2, 4. All right, if you'd like, you can take a look at example number 3 in your textbook, but it's going to be very similar to example number 2. So what I want to do now is I want to look at example 4, because example 4 is an example of a word problem. So we have 2 different types of tickets. We have adult tickets and we have child tickets. So we're going to let the variable A represent the adult ticket price and C represent the child ticket price. Now the Moores have 2A plus 3C and they spent $82. And then the Smythes had 3A plus 5 times the child ticket equals $130. So using the information on both families and how much they spent each, we can set up a system of equations and then solve in order to figure out how much the adult ticket was and how much the child ticket was. So since these are two equations, remember we want to pick one variable to solve for from one equation. So we're going to solve for A from the first equation. So we'll subtract 3c from both sides. So we have 2a equals negative 3c plus 82. We'll divide both sides by 2. And for this example, I'm going to just leave it as one big fraction because I can't divide negative 3 by 2. So I'll just leave it as one big fraction. Now I'm going to take this information for A, the expression that is equal to A, and substitute it for A into my other equation. So instead of saying 3 times A, I'll have negative 3c over 2 plus 82 divided by 2 is 41. So when I substitute that in, I'll have 3 times negative 3c over 2 plus 41, because that's what A was equal to. And then I still have the plus 5c equals 130. So we'll distribute this 3. So we'll have negative 9c over 2 plus 123 plus 5c equals 130. Now that we distributed this 3, what we're going to do is try to solve this equation for C, because now I only have one variable. So since there is a fraction, we're going to eliminate the fraction by multiplying every single term by 2. So we're going to multiply everything by 2. And then what happens, we will get negative 9c because the 2 cancels. And then 2 times 123 is 246. And then 5c times 2 is 10c, and then 130 times 2 is 260. Now I can combine like terms, so negative 9c plus 10c gives me just c, and I have 246 equals 260. Subtract 246 from both sides, and I get the c is equal to 14. So remember, c represented the price of the child ticket. So now that we know that the price of the child ticket, remember the adult ticket was negative 3c divided by 2 plus 41. So I can substitute 14 in for c, because that's how much the child ticket was, and then solve for a. So negative 3 times 14 divided by 2 is negative 21, and then negative 21 plus 41 is 20. So now I know that the adult ticket is 20. So now we just need to check and make sure that it makes sense. The discounted adult tickets are $20, and the discounted child tickets are $14. So if we related back to the story in example 4, these answers check, they make sense, right? They're not negative numbers, they're not super expensive numbers. Like, these numbers make sense with their story and they check. So that's a really good example on how to do a word problem and solve a word problem using a system of equations. Let's do another type of word problem with systems of equations. So for this example, if you'll take a look in your textbook, you'll notice that we are investing in 2 different accounts, okay? So what we need to figure out is how much we are investing in each account. So we're going to define our variables. We're going to let x be the principal amount in the account that has 2%. And we're going to let y be the principal amount in the account that has 4.5%. So we have to recall our equation for interest, which is principal times rate times time. Multiply those 3 together, and that's how you get your interest. So there are 2 different accounts, so we're going to set up a table. So we have the 2% account and the 4.5% account. So remember, we let x be the principal amount in the 2%, and we let y be the 4.5% principal amount. So the rate for the 2% is going to be 2% written as a decimal. So we'll move our decimal over to the left twice, and we get 0.02. So the rate for the account that has 4.5% is the decimal of 4.5%. So we'll move our decimal over twice to the left, and we get 0.045. Now, if you read the story in example 5 in your textbook, you'll notice that the time is over 2 years. So the time for each account was 2 years. Now, remember, to get this last column, the only way to get what's over here is to multiply what you actually have written in the previous 3 columns. So x times 0.02 times 2 is going to be 0.04x. Now, to get this one, we had to go back and multiply what was in the previous 3 columns. So y times 0.045 times 2 gives us 0.09y. So now that we have set up our table, we can set up our 2 equations. So we know that the total principal on both accounts has to add up to $20,000, which means x plus y is equal to 20,000. We also know that the total interest was 1,175. Both these pieces of information are in the story for example 5 in your textbook in section 7.3. So total interest was that last 4th column, which was 0.04x and 0.09y. So if we add those together, they are supposed to add up to 1,175. So now we have a system of equations. Here's our first equation, and here's our second equation. So we can use substitution, solve for one variable, substitute it into the other equation, and then solve for that variable. So x plus y equals 20,000. We can solve for y by subtracting x from both sides. And now that we know what y is, we can take y and put it into our other equation. Before we do that, let's go ahead and get rid of all these decimals. So in order to get rid of my decimals, I'm going to multiply everything by 100 so that way I can move my decimal over twice, and then I no longer have decimals. And then I will substitute negative x plus 20,000 for y. And then I have an equation that only has one variable. So now I can solve for x. I'll start with distributing this 9. So I have negative 9x plus 180,000. And then I still have that 4x, and I still have equals 117,500. Combine like terms, so 4x minus 9x is negative 5x. Subtract 180,000 from both sides. Divide both sides by negative 5, and x is equal to 12,500. So that was the principal amount in the first account. Now, since I know that x is 12,500, I can now solve for y, because y was equal to negative x plus 20,000. So that means I have negative 12,500 plus 20,000, which means y is equal to 7,500. So now we answer the story. Mr. Peterson invested 12,500 at the 2% and 7,500 at the 4.5%. All right, it looks like you are ready to try some problems on your own.